Okay, here we are. Section 1.5, solving inequalities, part 1. Right, your inequalities are your greater than, your less than, greater than or equal to, less than or equal to, approximately equal to, not equal to. Do not write this down. Do not. It's in your book if you need to look it up. The basic idea here is, I'm going to look at this side right here. If 3 is less than 5 and you subtract 4 from both sides, negative 1 is less than 1. I think the point they're trying to get at here is that your inequality doesn't change. It's just if this was less, if you do the same thing to both sides, this will be less. Same here, 2 is greater than negative 7. If you subtract from both sides or add from both sides, your inequality is not going to be doing anything crazy. It stays greater than. All right, so let's try a problem here. Example 1, solve 4y minus 3 is less than 5y plus 2. Graph the solution set on a number line. Not much different than solving an equation at this point. Now you have a choice. There's 4 different ways to start this problem. Some of you could subtract 4y, some of you will add 3, some of you may subtract 5y, some of you may subtract 2 to start the problem. What I'm going to do is get my y's together first. And which way your y is going to go, it doesn't matter. But you know what, I got to undo that already. I know that's not going to work because it's just not going to work. It will work, but not until I teach you another little thing in about 2 screens. I'm going to subtract 4y from both sides. So now this is 0, negative 3 is less than or equal to, nope, not 5y. Yeah, Mrs. Talley is losing it, it appears. Y plus 2. I want to get y by itself. I'm going to subtract 2 from both sides. All right, now this is 0. This becomes negative 5. This is less than or equal to y. This can also be written. Y is greater than or equal to negative 5. To put that on a number line, we have a solid circle at negative 5. Sometimes I write these above the line, but here I got a different color, so it's going to be okay. It's greater than negative 5. These numbers this way are greater than negative 5. So I'm going to draw my arrow like that so you can see it a little better rather than, just a straight line. Example 2, graph the solution to 6x minus 2 is less than 5x plus 7. All right. Once again, 4 different ways to start this problem. I'm going to subtract 5x from both sides to start. And you could do it differently, and we can still all end up with the same answer if we all do it correctly. All right, now I want to get x by itself, so add 2 to both sides. I'm not showing my work, but now I am. And now my answer is x is less than 9. If you have less than, you have an open circle. We do not fill that in, and we have everything less than, which means you go to the left of 9. So yeah, anytime you see this solid circle is anytime you have greater than or equal to, less than or equal to. You will put an open circle when you have greater than or less than. Don't write this all down either. They're basically telling you, look how this problem starts out, less than. You do a little multiplication here, and what did we do here? Negative 2, here's your 3, why did they take it times 4? Oh, they're taking both sides times 4. I'm losing my mind here for just a second. All right. And then this is a different problem altogether. Goodness. All right. So this one starts out 5 is greater than negative 1. Here we multiply both sides by a negative number, the sign switches. Same thing here with division. There's 2 problems here. We're going to divide by 3. Notice how the signs are the same. But here, when you divide by negative 2, your sign, your inequality changes. Okay, let me do that in Mrs. Talley's terms. This is what I do to explain this. You take any number on this number line, we're going to pair it up with this. It's kind of called a mapping. If you have the number negative 3, and I want to add 2 to negative 3, guess where it goes? Right down here. If I want to add 2 to negative 2, I get a 0. If I add 1 to 2, I get excuse me, if I add -1 plus 2, I get 1. 0 plus 2 is 2. 1 plus 2 is 3. 2 plus 2 is 4. Are we seeing the mapping there happening? Okay, you're like, no big deal, Miss Talley, what's the big deal? My point is, this number is less than this number. Even after you add, this number is less than this number. All right, let's move on. This time on these screens here, I'm going to multiply by 2. -2 times 2 is -4. -1 times 2 is -2. 0 times 2 gives you 0. 1 times 2 gives you 2. 2 times 2 gives you 4, and so on. This number is less than this number. After you multiply by 2, this number is still less than this number. Okay? Here's what happens when you multiply by -2. -2 times -2 gives you a 4. -1 times -2 gives you +2. 0 times -2 gives you 0. 1 times -2 gives you -2. And 2 times -2 gives you -4. Oh, look what's happening. This number was less than this number, but after it's been multiplied by -2, it comes over here, and now it's on this side, and this one's over here on this side. So now your inequality has switched. After this multiplication, the value has changed. One is now greater than the other one when it was less than before. So the big rule is, and hopefully this is just a reminder from Algebra 1, when multiplying or dividing by negative numbers, here's my quick thing, and I will even do a little demonstration in class. Switch the inequality. Okay, obviously that's pretty important. Take the time to get that in your notes. Example 3, let's try it out. 12 is greater than or equal to -0.3p. Divide both sides by -0.3. Here's the kicker. You're dividing by a negative number. Let me go back to that screen. When you multiply or divide by a negative number, you switch the inequality. This comes out to be a 1. Switch the inequality. 12 divided by -1/3. -36. Okay, if you want to put that in your calculator because you don't like what I just did there, go for it. -36 is right here on the number line. It is going to be a solid circle. P is greater than this, so it's going to go greater than. If you don't like the way this is written, you can switch it. Just make sure the alligator is still eating the P. Example 4. Now we got a fraction in there. Graph is the solution set. We got -x is greater than x minus 7 over 2. Here's what I'm going to do first. I'm going to get rid of the fraction. I'm going to take this denominator and multiply both sides by 2. So now I have -2x. I am not multiplying by a negative number, so I will keep the inequality the same direction, and now I have x minus 7. Get my x's together by subtracting x from both sides. I have -3x is greater than -7. I want to get x by itself, divide by -3, divide by -3. I'm dividing by a negative number. That means I need to switch my inequality. Negative divided by negative is positive. All right, so the trick is not that it's mathematically hard, it's that you got to remember when to switch your inequality and when not to switch your inequality. So 7/3 is actually the same as 2 1/3. Okay, and if you want to remember how to do that, you either calculator or 2 times 3 is 6. I got 1 left over. It's like a remainder of 1, 1/3. All right, 2 1/3 is right here on the number line. Open circle because I am not including it in the boundary, and I am saying it's greater than this. Oh, wait, stop. Stop, Mrs. Talley, before we screw this completely up. Guys, I'm just not paying close enough attention, am I? X is less than, what happened? Did I switch? Oh, I switched my inequality. Goodness. X is less than 7/3, so I gotta go over here. Sorry for any confusion. Example 5. Oh, good. We have another chance at this. Maybe I would normally have let you do this by yourself, but I think I better do another one for you. First thing I'm going to do is get rid of the fraction by multiplying both sides by 3. 3 over 1. This is like a 3 here. These 3's cancel. I have negative 6x. I do not need to switch the inequality because I multiplied by a positive 3. Okay, get my x's on the same side of the equation. I'm going to subtract x from both sides. And now I have negative 7x is greater than 5. Get x by itself, so divide by negative 7, divide by negative 7. Now that I'm dividing by a negative number, I switch the inequality, and my answer is negative 5/7. This would mean I would have an open circle on the number line, and I would have less than negative 5/7. One more, example 6 here. We're going to graph it after we solve this. It gets a little more complicated. From this right here, the first thing we're going to do is distribute. Save me one little step here. So I have 3m plus 15 greater than or equal to 4m plus 12. I'm going to combine like terms over here. So I have 3m plus 17 is greater than or equal to 4m plus 12. I'm going to put my m's on the same side. So I subtract 4m from both sides. 3 minus 4 is negative 1m. Plus 17 is greater than or equal to 12. Subtract 17 from both sides. That's negative 5. What I say in this case is switch, switch, switch. Or you can say, hey, divide by negative 1 or multiply by negative 1. In which case, negative m becomes positive m. The inequality switches the sign, or the way it's pointing, and then we got 5. So m is less than or equal to 5, which means I have a solid circle at 5. Less than goes this way. And that's the end of this portion of the lesson.